So let's talk about our warm-up. Today is our last lesson day for Unit 8. Like I said before, short, quick, only a quiz. Next time you'll review, and then the class after that will do our quiz. So keep that in mind. After class today, you should be able to complete all of your Delta Math homework. And if you don't have it all done by next class, that's okay. You should have some time where you could work on it too. So let's talk about our warm-up. We have to compare the SAT versus the ACT on like how you did on those tests. You could only submit one score on your application. Alex? Yeah, just no passing. So with our SAT versus ACT, anybody want to tell us what score should we submit? Let's just jump straight to the answer and then work our way back. ACT. So Evan's telling us we should submit the ACT over the SAT. How do you know what score to submit? What should you do to be able to compare those since they're on different like scaled scores? What do you think, Cash?
Whichever one has a higher Z-score.
Awesome. You're looking for a higher Z-score. So I want to calculate the Z-score for both. Think about your Z-score formula. I wrote it on the board for you. I don't know if I mentioned it last time. Girls listening in. I am going to give you the formulas that are on the board over there on your quiz. We'll kind of talk about the other two today. So for your SAT, what is your X? What was like the X value with the SAT?
440.
Yeah, it's your score, 1240. It's the data point. And the average was 1028. And you're going to divide it by 35. What did you guys find that Z-score to equal? 0.6. All right, and then our ACT, what was our X value? 29, your score minus a, you're right. 21 minus the average of 19.5 divided by standard deviation of 0.24. And what was our Z-score here? 6.25. So Cash explained it really nicely earlier. You're looking for a higher Z-score. Since those two are compared on two totally different scales, you can calculate the Z-score for both as a way to figure out how you are relative to the mean of the distribution, the average. So you want the highest Z-score because you're furthest, that means in the highest percentile above your mean. So you should choose your ACT because we have a higher Z-score. All right, last time and the time before that, we kind of looked at probability. Today it's a little different, and we are looking more into like kind of situations in which like different combinations and like things can occur. So if you have a phone, right? A lot of times you got to enter a password to get into your phone. Like mine's like 4 digits. So something that maybe you could answer by the end of class today is how many possible combinations are there to unlock your phone? So that's what we're looking for today, situations like that. So let's get started, and we're going to first talk about factorials. So if you've ever seen something in math that looks like an exclamation point, that's a factorial. So 9 factorial is like as simple as 9 exclamation point. You're not just really excited about the number 9. It is a way to mathematically express 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So for factorial, you're starting at the value that you're given, and then you work back all the way until 1. You're multiplying by every single number in between. So obviously I'm stopping at 1, not including 0, because then 0, just zero everything out. So you could do 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1 in your calculator. But if you like to be a little bit more efficient, I'll show you how you can find factorial in your calculator. So first, we are always going to hit the value, which is going to be a common theme for today. So I'd hit 9, and then you go to math, scroll to the right for PRB, option number 4, then you would see 9 exclamation point, which means 9 factorial, hit enter, and you'll get that value. What was it? 362,880. Was that it?
Yeah.
Thanks. So we're going to use factorials, the ideas of that today, and you'll use them a lot in kind of future math classes you take beyond that too. And what we're going to discuss first is the fundamental counting principle. So it's not just, hey, how do I count? It's talking about if one event occurs m ways and the other event occurs n ways, then the number of ways that both events can occur would be m times n. So here's an example looking at the fundamental counting principle. A restaurant menu contains 8 entrees, 2 salads, 6 desserts, and 12 drinks. How many different dinners consisting of 1 entree, 1 salad, 1 dessert, and 1 drink can you choose from? So we have different events when you're thinking about creating this dinner for yourself. So one thing you're going to include in your dinner is your entrees. How many entrees do we have to choose from? Yeah, and then we also have salads. How many salad options do we have to choose from? 2. So I'm going to multiply these events together. And if I was only getting an entree and salad, I'd stop there. 16 possible combinations, right? Think about it, I could have 8 entrees, and then from each, if you've ever done, oh, you guys definitely did this in elementary school, right? You took those branches, right? Made those like trees. This is much quicker for us to figure these out. And then we have 6 desserts after that, and then 12 drinks. So you obviously wouldn't want to do those trees, right? If you have all of these different values. So you're just going to multiply all those together for all those different combinations. Let's say you go to that restaurant all the time and you're like, I want to try every single combination there is to do on the menu. How many different combinations would we end up having here? What did you find, Yalda? 1,000, what was it? Thank you. And then, why don't you guys read over question 2 and think about that one for a second. So I want a new outfit, and with my new outfit, I'm going to get a new coat, pair of pants, and a tie. So my options for a sports coat, they come in 6 different colors, pants come in 4 different options, and then there's 25 ties after that. How many different possible combinations do we have here? What do you think, Laura? How did you get 600? Yeah, so you did 6 times 4 times 25 to get 600. Alright guys, what questions do you have here? So this is fundamental counting principle distance of, with each, you're kind of like choosing one option each time and there's different events. So let's talk about other scenarios we're going to come across. And our first is a permutation. So this is going to be when a group of objects or people are arranged in a sort of order. And order does matter. So in this example here, there's 8 runners, and we want to know how many ways can they finish first, second, and third. So the order matters when you are running a race, right? How you finish the race. Getting like Sabina first, Vita second, and McKenna third. Right? That order matters there. Think about a different order is created if McKenna's first, Sabina's second, and then Nikita's third. Even though there's like 3 of them, does everybody see there's like those orders are different? Those possibilities are different. So I want you guys to, before we kind of go over like how it's calculated, I want to see if you guys can figure this out on your own in the sense of like, what could this be equal to? So I'm going to give you guys a couple minutes to think about it with your table. See what you come up with. Are you guys, anybody have any ideas that they're predicting things might happen? Anybody have any ideas? What are you thinking, Yoda?
So for third place, you have like 8 options, but then you have the second place, you only have 7 options.
Yeah.
And then when you go to first place, you have 6 options.
Good. I like the way you're thinking about it. I'm just going to kind of like go in reverse. Meaning, if I'm running a race and there's 8 of us, all 8 possible for first place until that one person crosses the finish line, and then there's 7 of you left after you have for second place. And then after the second person or second place person crosses, there's 6 more left. That would be for third place. Good. So our order does matter here with that situation. So let's think about another type of situation, which would be combination. So that's when the order of an arrangement or selection does not matter. So meaning, it didn't matter that before, like the order for like Sabina, Vita, McKenna mattered, but now it wouldn't matter here. That would mean Sabina, Vita, and McKenna all get medals. They're all participation trophies. You know those 3, they cross the finish line, so those 3 are the winners. So there's no specific first, second, or third to like place them. They're all just the winners in the book here. So that is combinations. So your order does not matter with a combination. So kind of think about with a combination, other situations might be if you're going to the ice cream store and you're getting a bowl of ice cream with multiple scoops of different flavors. Doesn't matter that, let's say there's like 10 different ice cream flavors. Does it matter that I have cookie dough and chocolate in my bowl versus chocolate and cookie dough? No, right? I get both of them together at the same time. So that would be a combination. So for here, Sydney has 8 best friends, and she wants to know how many ways can she choose 5 to be bridesmaids. They're all being selected, a part of the crew. It does not matter the order in which they're chosen. So see if you guys can kind of come up with this situation. This one's a little trickier. All right, so this one is a little trickier. Did anyone come up with any situations here to figure it out? So it's going to start off similar to before. So Sydney has 8 friends. She has 5 slots for those bridesmaids positions. So for your first slot, you can choose from any of your 8 friends, right? And then you did choose one, so how many are left for the next spot? 7. And then you have 6. And then you have 5. And then you have 4. So that's my 5 spots for my bridesmaids. But within that, we have to get rid of like your repeats. So like before when I had like Sabina, Vita, McKenna running that race. So Sabina, Vita, McKenna, it with a permutation is different than McKenna, Sabina, Vita. With a combination, they are the same. So we have to get rid of those repeats here. And within those repeats, that's within your group of 5 that you have, right? Like friend 1, 2, 3, 4, 5 would be the same as friend 5, 4, 3, 2, 1. So within those 5 mix-ups, we're going to have to divide by to get rid of. So from here, thinking about 5 factorial, I would know it would be 5 times 4 times 3 times 2 times 1. So what would we be left over with?
67.
67?
Times 2.
Try again, I don't think it should be decimal. 8 times 7 times 6 divided by 6. 56. So there's 2 different formulas that are created here. I wanted you guys to kind of see the reasonings with some examples behind them. And our 2 different formulas are permutations versus combinations. So you don't need to memorize these. We are going to use the calculator for this, but I wanted you to see what are those formulas, where do they come from. So we have NPR. So with each, you need to always know what your N value is and your R value. N is like how many possible objects or whatever you have to choose from. And R is the amount you are choosing. So if I'm thinking about my track situation, I had 8 runners. That is my N. And I had R places, right? I had first, second, third. So I have 3 places there. So looking at that formula, what you would have created would have been 8 factorial, which would be 8 times 7, 6, 5, 4, 3, 2, 1, all over N minus R factorial. So 8 minus 3 would be 5 factorial. And 5 factorial I know is the same as 5 times 4 times 3 times 2 times 1, which means that's why I'm left with 8 times 7 times 6. So let's go over how we figure this out in our calculator. So everybody turn on your TI calculator. And the number one important thing to remember is you always, always, always have to hit your N value first. Because it needs to pull a number from for your N. And if you just hit, kind of go through the steps, it's going to pull whatever number was last. So, clear out your calculator. And what's our N if I'm using this situation here? 8. So you did 8. I'm going to go to the math button. Right click over to probability. And NPR to calculate your permutations is option number 2. Now, yours might look a little different, but now it's your space where you enter your R, which we know here was 3. So you should have done 8, math, NPR, 3. You did that, hit enter, and you will find what we got, which was 336. If you got that, you're on the right track. If not, ask a neighbor to look at your calculator, see what you did wrong. So for your quiz, if you would like to use the calculator for it, that's great, that's fine. I'm okay with that. Here's the amount of work for the expectation I expect to see. I expect to see your N, your R, and U stating that is permutation. So 8, P, 3, you write 336. That would give you full credit for showing work and getting the right answer. So let's talk about combinations. Same idea, where your N is still like your amount you're choosing from. So this is our bridesmaid situation. Our N here was 8, and our R that we were kind of choosing from those 8 friends was 5. As a helpful hint, tip, and trick, your N value always, 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 always has to be larger. So if that's not happening, check yourself. Looking at the formula, we had 8 factorial. So 8, 7, 6, 5, 4, 3, 2, 1. And that was all divided by N minus R factorial, which would have been 3 factorial, which goes swoop, swoop. And then R factorial, which was 5 factorial, which is kind of what we got when we were working through it. So same idea in your calculator is you have to always hit your N value first. So let's do this one together. How, or what should I enter first to calculate this combination? What always goes first? N, what's our N here? 8. You're going to go back to math. Right click over to probability. What is this option we're going for a combination? 3. And our R here was 5, which gave us 56. So here's your work that you would need to show. N equals 8, R equals 5, 8, C, 5 equals 56. And then you'd be all good. All right, what questions do you guys have with the calculator? So before we look at more examples, I am going to show you how to do it with Desmos. So once again, if you are taking the SOL, so my freshmen in the room, or if you don't have a TI at home, you're welcome to use Desmos to calculate this. And always with Desmos, you can get any function you're looking for by going to Math, Functions. Here it's going to be all the way at the bottom, NPR and NCR. And you're always going to do your N value first still. So 8, 3 to get that value. But you know what I like to do that I think is just like a little easier in my life is I like to just straight up type it. So you could do lowercase n, uppercase C, lowercase r, and then you do 8, 5 as well. So another option to get your values there. All right, any calculator how-to questions? Okay, let's look at our examples then. If you forget, there's reminders in the slides for you too. So I'm going to give you guys a minute. Read through questions 1 and 2. The biggest thing with this, right? It's not that difficult to push some buttons in your calculator. The only thing that's difficult about this that you have to really think about is what type of situation do I have? Do I have a combination? Do I have a permutation? So that's really kind of your decision-making thought process here. All right, everybody. Let's look at question 1. Allison's adopting kittens from the pet store. There's 18. How many ways can she choose to? So our first decision, combination, permutation. What do we think? Yeah, how do we know it's combination here? Does not matter what order I pick the cats in, they're both coming home with me, right? So I know it's a combination. Now I need to know what's my N and what's my R. What's our N here? How many cats do I have to choose from? Yes. And what is our R? How many are we choosing? 2. So you have 18C2. And if you did that, what did you find that's equal in your calculator? 306. Does that sound like what everybody was getting? I don't know, I haven't done it. What? 18. And then the C2. Was that the other one? Was it 152? 153? So with question 2, there's 14 players on the baseball team. How many ways can the coach pick a 9-player batting order? If you're playing baseball, your batting order, does that matter? Yeah, right? So that's the order does matter here, which means it's a permutation. So what's our N and what's our R? What would N be here? 14. And what's our R? 9. What did you guys find that's equal? Like a big number? Just yell it out. What is it?
26,485,760.
700 and then what? Did I get it all right? Okay. So obviously it's not going to stay quite as simple with that. Like it is, we're going to now do some compound events, which means more than one situation's happening at a time. So maybe you're at the shelter, there's 18 cats, and you choose 2, but then you also have 10 dogs, and you want to choose 3 dogs to take home too. So that's a compound event, right? This situation for cats, situation for dogs. We're going to do those together. So with your compound event, and a lot of you guys saw this with the classwork last time. The last problem, it was like your probability to be less than a value and a probability to be greater than another. And some of you guys had that thought process already, like, oh, I should add those probabilities together. Because that was an or situation. It was like less than some value or greater than another value. So that's or. But if you're having both at the same time, like I'm coming home with both cats and dogs, I would have to multiply those events together. So looking at our example, there's 10 juniors and 14 seniors in the leadership class. And the committee is being formed of 2 juniors and 3 seniors to organize a fundraising project. I want to know how many different committees could be formed here. How many different combinations can be created for this committee? So we have juniors and seniors that we have to think about. So let's kind of do those individually. So with our juniors, how many juniors do we have to choose from? What's our N here? Yeah, and how many are we choosing? 2. What would this situation be? Combination or permutation? Combination. It doesn't matter the order that I'm choosing them in, right? You're all a part of the committee. So that'd be 10C2. What about for my seniors? How many seniors do I have to choose from? And then how many are we choosing? 3. What type of situation was this? Does it matter the order? Nope. So it's combination, so 14C3. Now, what should I do with those 2 values if I'm doing juniors and seniors? Multiply them together. So I'm going to give you guys a minute. Figure out them individually, multiply them together, and then we'll do the total. What did you guys find for our juniors? What are the possible combinations there? 45. What about for the seniors? 364. and then multiply those together. What did we find that's equal? $16,000 and then what? How does that sound with everybody? Those are the numbers you're getting? Remember, multiplying those together because it was an and situation. What questions do you guys have here? All right, let's look at our last example. I'm going to kind of have you guys work on this on your own with a bunch of your table, and then we'll go over it like 4 minutes. All right, guys, so you have 52 cards in a deck, and there's 4 suits of 13 cards each, and you're playing a game with a friend, and you guys draw 5 cards from a deck. So how many different hands are possible if you just draw 5 cards? Anybody have any idea what would our N be here? How many possible cards do we have? We have 52. And was this permutation or combinations? Combinations, right? It doesn't matter the order that I'm given my cards. They're all in my deck, or they're all in my hand at the end. And I have 5 that I'm given. So that's my R value. What did you find that's equal? Anyone find a value there? If not, calculate it real quick, see what you find. Speedy, did you find it? Yeah? What did you find your value to be?
598,960.
So does that sound about what you guys were getting? We calculated it? Yeah? Okay. So how many hands can be created with 3 clubs and 2 hearts? So we have 2 situations going on here. 3 clubs and 2 hearts. So thinking about your 3 clubs. In my deck, how many clubs are there for me to choose from? 13. So that's my N value. Already talked about this is combinations, doesn't matter the order I've given them. And then out of those 13, how many could be clubs? 3. And so that means I'm going to do what with these values? Good. So I'm going to multiply it by 2, getting 2 hearts. So how many hearts do I have to choose from in my whole deck? 13. I'm getting 2. So take a minute, calculate that if you have not already. Find those 2 and then multiply them together. Anyone see how many combinations there are to have that? What did you see, Mithra? I heard 22,000 and then what else after that? All right. Part C, definitely the trickiest so far. So let's talk about how many hands can be created with at most 2 spades. If I have at most 2 spades, what other situations fall under that umbrella? That'd be having 2 spades. What other situations would that be?
1 spade.
1 spade and also no spades. So we have to think about those 3 situations. So I'm going to have 0 or no spades. I'll also have 1 spade and 2 spades. So thinking about what's going to be happening here, I could have no spades or 1 spade or 2 spades. So what should I do with those 3 values? What should I do? Should I multiply or add them together? Add. You heard me. I said I could have no or 1 or 2. And all of those could fall under that umbrella. So if I have no spades, how many possible cards are not spades? How did you get 39, Vivian?
Subtracted in 13 from 52 since you're eliminating a suit.
Good, you're eliminating that suit. So, how many am I going to choose from in my deck, in my hand? I'm going to have 5 of those. Now we're going to add that to 1 spade. So in my deck, I will have 1 spade, and what else would I have? 4 other no spades. So if I have 1 and 4 no spades, I'm going to have another kind of compound situation within here. So if I have 1 spade, well, how many spades do I have to choose from? 13. And I'm going to choose 1 spade, and I have 4 no spades. What would that look like? How many no spades are there to choose from? 39. I'm going to multiply 39, choosing 4. Multiplying those together, so I have to have that and that at the same time. Then lastly, we have 2 spades and 3 no spades together. So 2 spades, what would that situation look like? Great. What about 3 no spades?
39 FC3.
Good, 39C3. And I would multiply those 2 together. So I'm going to give you guys a moment to calculate that all out, see what you found that to equal. It's going to be a wild, crazy number. So think about multiplying these, and adding kind of all 3 of those ideas together. It's going to be a big, wild, crazy number. Anybody found that value yet? Still calculating it? I have 2,357,000 and then
862.
all right, if you are still calculating it, I want to double check. I'm going to leave this slide up here for you. I am going to go ahead and pass out your classwork that you're going to get started on next.